OCI, Orange County Inspections, is glad to present the QC and QA Professional Seminar, segment number 6. This segment, we will cover the visual tools and terminology that every professional should know. First, we will cover the weld symbol, which drives the production of structural steel industries, whether that is in the shop or the field. Next, we review the parts that make up either a fillet or groove weld, which include items such as the fillet leg length or crown of a groove weld. We then move into weld defects. We will see examples of cracks, porosity, and even technique problems that will help you understand why they happened when you come across them in a shop or the field. First topic is the weld symbol. At first glance, this symbol is very confusing, but as always, let's break it down step by step. We will reveal the actual weld symbol, which we have here. This is the weld symbol, and now we will cover each notation that you might come across in the industry. The arrow will point to the workpiece that will be welded, and the tail is where special notes or instructions will be placed if the notations do not satisfy the information that is needed to be passed on. Here we see the highlighted section, which is the arrow side of the symbol. And what does that mean exactly? Okay, well, we have here an actual fillet weld assembly that you might see in a shop or the field. And with our weld symbol example, if the arrow is pointing to the workpiece on this side, it would mean the information below the line is also shown on this side. Now, we know what the arrow side of the symbol is, so let's take a look at what is called the other side, which is found above the line on the weld symbol. Again, on our weld assembly, it would be on this side. Let's look at an actual groove weld assembly, and here is the arrow side, the top of the weld, and the other side would be here. Back at the weld symbol, we cover the actual body line, the arrow and tail, plus we see that there is the arrow side, which is on the bottom of the line, and the other side, which is found above the line. Now, we will cover notations of importance. There is a black flag shown here, and that represents field welding. And if there is no flag, that would mean it's welded in a shop. We see a circle at this point of the symbol, which stands for the weld being produced all around the workpiece. Here we have an L, which is where a number will be called out for the weld length, and the P will have a number representing the pitch spacing or center to center spacing of the welds. Moving up the symbol, we have an A, which will have a degree number for the groove angle required. Now we have three different notations. First, the F will have a symbol for the finish of the weld face. Second, the line will have a symbol for the finish contour of the weld face. And the third notation, which is the R, will have a fraction number for the root opening. The E in parentheses will also have a number for the effective throat of a groove weld. The S will have a fraction number for the depth of preparation for the groove bevels. The N in parentheses will have a number for the count of spot or projection welds. Here is a very important note for all personnel. All these notations will remain the same even if the symbol is reversed. And this last location will be for the different weld symbols that can be placed on either or both sides of the line. We will now take a closer look at these. Okay, before we dive into the different symbols for each type of weld and finishes, we need to understand there are situations that require these symbols, and that will start with the 5 basic joint types that are created with connections of structural steel material. The first joint is the butt. You will have 2 different plates that will be fused together by the actual weld. The next joint is the corner. Here, 2 plates will make an actual corner where the weld will be placed. The third joint is the T. Here, one plate will be placed on the other to create a T, which the weld could be placed on either side of the vertical plate, as in the picture we used for our weld assembly example earlier. The fourth joint is the lap, where one plate is laid on top of the other, in which the weld can be placed on either end of the plates. And to close this topic is the edge, where the 2 plates can be placed together or separated on an angle, but the weld is usually placed on the edge of the plates. Let's look at some basics of the fillet and groove welds, because without the foundation being understood, there is no need to try to learn more advanced symbols. Starting with the fillet weld assembly, we have a T-joint, and here is a typical weld symbol drawing we might see for it. We see the vertical plate on the weld assembly, and then the same plate on the symbol drawing. Next, we see the horizontal plate of the T-assembly, and the same plate represented in the symbol drawing. The red line is running across the fillet weld, and the arrow of the weld symbol shows where the fillet weld will be, but here we tried to show where it would be with this side view. Next is the groove weld assembly, and here is a weld symbol drawing for it. We start with the plate on the left side on the actual weld piece, and here is the plate represented on the weld symbol. Next is the plate on the right side, and again here is the plate represented in the weld symbol. With groove welds, there are times a backup bar is required, and here the arrow reveals the backup bar on the weld assembly, and the arrow reveals where the backup bar would be found on the weld symbol. And lastly, the red line runs where the groove weld will be placed, and the arrow shows the actual weld location on the weld symbol. So before we move on, the principles with the fillet and groove welds are the same. They both connect the 2 pieces of material with a weld bead. So with a fillet weld, the weld bead is more like a triangle, which needs 2 different directions of plates, while the groove weld is filling in the gap between the 2 pieces of material. Well, we now have a better understanding of the different joints and the basic principles behind what a groove and fillet weld require. We can now move on to more advanced welding symbols. And here are just a few weld symbols that you, the QC and QA professional, could and will run up against in a shop or field someday if you haven't already. Let's take a look at these symbols and the actual weld symbol. We start with this first group, the fillet, and here think of a shark fin. And what do you do to a fish? You fillet it. Next are the plug or slot, and this will be seen more for deck welding. Last in this group is the spot, projection, and seam, which are used more in the automotive industry. We move to the second group of symbols, and the back or backing is shown, which is used at times as a backup bar. Now is the melt-through, which is used on industries like food processing or pressure pipe assemblies. Here is the surfacing, which is used to build a protection on things such as dirt moving equipment buckets or blades. And lastly in this group are two different weld symbols. The first is the edge flange groove, which is usually a corner on a bent plate welded to another corner of a bent plate. And second is the corner flange groove, which is found when a corner of the bent plate is welded to a flat plate. Here we see the third group of symbols that are used for the groove weld assemblies. We start with the square, then the V, and the bevel. We have included all three of these together due to the fact they are the most used. Each can be used on the minimum plate thickness allowed by the D11 to the maximum plate thickness. They are used on simple connections to special moment framing connections and everything in between. The next two symbols, the U and J, need some type of preparation from a source like a grinder, torch, or air carbon gouging process. And finishing this group are the flare V and flare bevel, which are similar to the edge and corner flange we saw earlier. And last group for review are some symbols we have covered earlier, but do have a few new ones also. We have the all-around weld, which has the weld bead starting and stopping in the same location on the workpiece, whether that direction is vertical or horizontal, and even at times it will include both directions. Now we see the flag, which means it's being welded in the field, and at times you will see the flag not darkened, which stands for the same condition. Next is the three different contour finishes that a weld bead can have. The flush will take some form of action with tooling to create this finish, where the convex is typically created when a weld bead is performed correctly, but in the food and petroleum industries there are times for more of a finish height for corrosion purposes. And lastly is the concave, in which is found when back gouging of a weld assembly is required for completing a full penetration weld. As we close the weld symbol topic, we hope you understand the first step is to understand which type of joint is being used. So ask the question, is it a butt or a T, etc.? Then the second step is to ask, is it a fillet or groove weld being called out? And then finally, for the third step, just follow the symbols being shown that will create a correct welded assembly. We move into the parts that make up a fillet or groove weld, and we start with the fillet weld. Now on the right top corner we see what the actual fillet weld assembly looks like, and we will take a cut view through the fillet weld bead. Looking at the cut view of the fillet weld back on the left side of the screen, we must start with the basics, which is it takes two legs to create the fillet weld, and the third side is the face of the weld, which creates a triangle shape. Now, with the weld bead basic understood, the next is to see how there must be two different directions of material to form this triangle bead. So first is the vertical plate, and then the horizontal plate that act as a form to hold the melted metal as one. So we see the need for two plates that create a triangle bead. So now the fillet weld size is determined by the length of each weld leg. So measure the vertical leg at what is called the toe, and then the same location of the horizontal leg. And whichever leg is the shortest will be the weld size. Now in some cases you could be using an uneven fillet weld, that will have you measuring each leg separately from the other. To cover a few other items in this diagram, there are dashed lines which represent the theoretical outline of the weld. And notice the outline area of slanted lines just under the weld bead, and this is the heat affected zone. That is created when the weld heat is introduced. Now we will look at the parts of a groove weld. There again, taking a cut view through the weld bead, and first it takes two different plates, and in this diagram each end of the plates have been beveled to make the required angles, which then the gap is filled in with weld metal. A few items of interest starts with the root opening found at the bottom of the weld joint. Next is the face of the weld, or the proper terminology is the crown. Now notice the toe found on each side of the crown. Here, the height in which the crown is above the plate material is called the reinforcement. And when heat is introduced to metal, there is always a heat affected zone. Before we move on to the next topic, I would like to make a point on how important it is to know and understand these items for you, the QC and QA professional, because you will need to communicate not only with the welders but also design professionals at some point of the project using these terminologies. The last topic of this segment will be weld defects. Now, there are many different defects that AWS covers with many of their information guidelines, so here we will cover a few that are usually found in both the field and shops. First is a crack, and we see here it's running with the weld bead face, and next we see another type of crack, the crack running off the toe. Both are important to find with visual, if possible, but this is why UT inspection by the third party is so very important. Second defect is the undercut. This is found at the toes of the weld bead and usually looks like a melted trench running along the weld bead length. Third defect is the overlap. And here we see how the weld bead has bubbled over at the toe of the weld, and usually this is because of low current or slow travel speed. We'll move on to more defects, and the next is excessive reinforcement. Remember, it's just having too much of a crown on the groove weld face. So here is the actual reinforcement and the area in which the excessive reinforcement is found. We move to a very typical defect if moisture is around, and that is porosity, which is best described as little pinholes. But there is another type of porosity that resembles linear grooves, also known as worm tracks. And the last defects are the actual weld bead themselves that are affected by the weld current and techniques. So we see some major example of weld beads. First, we see a proper weld bead which has the proper current and technique. Now we see a set of weld beads which show the current being too low then too high. Notice the difference between these two and the proper weld bead. Next group, which is a technique problem, here the arc length is too short then too long, which means the electrode tip is either too close or too far away from the weld arc. And we close with another type of technique problem, the travel speed being too slow then too fast, which once again means the welder is moving the electrode too slow or too fast across the weld piece. We have come to the end of segment number 6, and let's review the topics covered. First, we review the actual items that make up the weld symbol, from which side of the line the arrow represents, to what the notations on the symbol stands for. Next, we reveal the 5 common joint types, with those being the butt, corner, T, lap, and the edge, which took us into learning the many different weld symbols and parts of a fillet and groove weld. And we close with visual examples of some common weld defects, which are found not only on the weld assembly, but also are caused by improper weld currents and techniques. To finish this segment, 1. Complete the study material. 2. If any questions arise, just email us at orangecountyinspections@yahoo.com. Then move to segment number